Okay, so y equal 5 sine 4x minus pi. This is the review for your test. So remember, it goes a, w, and then phi.
Hey, Mr. Creaky, sir, I don't have the review.
I gave it on Friday, just a second. Yeah. All right, so your formula has a for there, w for there, and phi for there. Okay, so your amplitude is 5. It has to be positive. Remember, the w represents the frequency, which affects the period. Okay, so for the period, that formula would be t equal the normal period divided by w, and the normal period for sine is 2 pi, so we get 2 pi divided by w, which is 4. 2 pi fourths, you need to simplify that to pi halves. Remember that if you end up with a negative period, you got to make it positive also. So both of those have to be positive. This one could be positive or negative, the phase, just depending on whether you're going right or left. Okay, so your formula for the phase shift is phi divided by w. So your phi is pi, and your w is 4. Yeah, so you get pi over 4. Another easy way to remember it is it's right over left and change the sign. So in other words, the pi is what I'm saying on the right, the 4 is on the left, and then change from negative to positive. Okay, right over left and change the sign. It's phi over w. Okay, so here's a hint about this type problem. On this particular one, all of these start with pi fourths. Sometimes you're going to have two that are the same and, two others. So on this one, we know that it had to be pi fourths. So let's graph. Five sine 4x minus pi. Okay, there's your graph. So we basically want to go from like pi fourths to 5, and from negative 5 to 5 for y, because our amplitude was 5 and there's no vertical shift. So go to your window settings and change it from pi fourths to 5, and then this from negative 5 to 5. Okay, there's your graph. At the pi fourths, it's starting to go up, which means this one, okay, can't be this one. Could be this one, but then not this one. So we know that it's going to be either A or C, right? Okay, so then our next step is, remember these numbers represent x-intercepts. So we know that the main question is 3 pi eighths x-intercept question mark, 3 pi fourths x-intercept question mark. Because both of them have pi fourths and pi halves, so we got to just decide on those. So one way to tell is to go to your table, so Control T, go to your settings, and change independent to ask. So table, settings, and independent to ask. And so then when we hit 3 pi eighths, it says 5. So I put no. it's 3 pi 8 comma 5. And then this other one I put 3 pi over 4. And in this case, it says 0 there, but then down here it says 1 e to the negative 12. So you do need to be able to interpret that. If you have 1 e to the negative 12, that means point and then 11 zeros and then a 1, and so your answer would be 0. So it is an x-intercept, and so it's C. There's also some other times you have to interpret, like for vertical asymptotes, if you have e to a positive number. But we'll talk about that when we get to it. Okay, so there's number 1. Okay, number 2. This one's cosecant, and so we have an amplitude of 2. There's no number in front of x, so we know our w is 1, and we know our normal period and period are 2 pi. Because it's everything, it's always 2 pi except for tan and cotan. Okay, so what we need to do is graph this and look. All of these, by the way, have negative 2 pi to 2 pi. So that's the window we're going to use for the x's. 2 cosecant x. Okay, so we want a window from negative 2 pi to positive 2 pi. Now, some of these say from negative 2 to 2, and some of these say from negative 4 to 4. So I'm going to put negative 4 to 4, and then I might change it. Okay, so this is the one from negative 4 to 4. What we notice is at 2, you're going to have a minimum. So how you can be sure if you really need to do it this way, go to Analyze Graph, go to Minimum, and between here and here, you've got 1.57, comma 2, which means pi halves. So that's a minimum. So based on that, it can't be this one because the minimum's at 1. Because it goes 1, 2. Correct. Correct. And if you do your maximum, analyze maximum from here to here, it's negative 1.57, negative 2. So that would be negative pi halves, negative 2. All right. So now what I would do is I just look at my graph, and to the right of the y-axis it's up, and on B to the right of the y-axis it's down. And so it's not B because of that spot, but it is C because of this one. So you could use your minimums and maximums to be helpful. Now, if you do that, don't get confused with this part for your domain, because those aren't going to be the same. The domain part has to do with the asymptotes. So let's work on that. We've got 2 pi here, which is an asymptote, and we take half of that, which is pi, and that be an asymptote. So I kind of get it from the graph, and I already choose it. If you are struggling with it, which is okay, what we would do is check out the choices, it says odd integer, and so you'd say 1 times pi over 2, and then 3 times pi over 2. And then on this one, for odd, 1 times pi over 4, and 3 times pi over 4. And then this one just says integer, so you'd say 1 times pi and 2 times pi. Okay, so what I'm going to do is I'm going to check my table. So go menu, actually just go Control T, go to your table, and go to your settings, change independent to ask. Okay, so now it's all blanked out. So when I do pi halves, this shouldn't be surprising, but I'm going to do it anyway. I get 2. It's not a surprise because we knew that. Okay, so that means it's not that one. It would have to be undefined. Yeah, and at times it says something else, but I'll get to that. So here I'm going to do pi over 4, and I get a number, 2.82 something, and so it's not that. Now I'm going to get pi and hashtag undefined, and 2 pi, same thing. Okay, so those are hashtag undefined, and that's what we want. Okay. Okay, then for the range of cosecant, it is above and below. So remember, if it's cosecant or secant, it's going to be the one with the or. So in other words, it's 2 or higher, and it's -2 or below.
Are there any ones that we're going to find that have and?
If it's sine or cosine, because then it's between. Yeah. Good question. Okay, so there's 2. Anything else about that one? Okay. Next we have 3 secant 1/6 x minus 2. So we know amplitude, W, and phi. So the first thing I do on this one is try to figure out which graph. And in order to do that, I see some of these go to 12 pi, but this one goes to 2 pi. And so I want to rule out choices like right off the bat. Period is the normal period divided by W, which would be 2 pi divided by 1/6, and act like it's 2 pi over 1, so you get 12 pi. So remember on the homework we said, well then we're going to set it from -12 pi to 12 pi. So it's not this choice. Okay. Now for the next part, we've got a middle that's at -2. Middle y equal -2. And our amplitude's 3. So that means for the y part, we're going to go from -2 minus 3 to -2 plus 3, which basically is -5 to 1. Okay, let's now graph it. I think that part's going to be useful when we get to here, because it's secant and it's an or, and we're using -5 and +1. So that's going to be, I guess that's not really our window, that's going to be like our points that we're going to use, our y values. Anyway, let's graph this. 3 secant 1/6 x, and then outside the parentheses we go -2. Okay, well that's just centered to the y-axis, which means it's symmetric, just like cosine would have been. And let's change our window from negative 12 pi to 12 pi. Okay, now looking at these things, these say negative 10 to 10, so let me just, well, this one says negative 2 to 2. I'm going to use negative 10 to 10. So this part is for the minimums and maximums. This part, the negative 5 and the 1 are for minimums and maximums. Okay, so it's centered right on the y-axis, and it's up. This one's up, and this one is not centered, so it's not that one. This one's centered, but it's lower, and it also just went to 2. So we know that we're at the A graph. Okay, that's our A graph. And so now relating what I've already written, the negative 5 would be the y value for a maximum, and the positive 1 would be a minimum, the y value. So that's how this part relates to what the graph is. Okay, so the next thing, again, if you know the right graph, and then at 12 pi, if you look up or down at that spot, it would be a number, and so that means it's not going to be 12 pi. If I take half, I get 6 pi, which would also be a number. So this is actually, let me write it there, 6 pi comma negative 5. So that means this one is between 0 and 6 pi, which is 3 pi. And this one is between 6 pi and 12 pi, which is 9 pi. That's where the asymptotes are. And so at that point, I'd say, oh, I recognize 3 pi as D. So that's how I do it a lot. If you'd rather go to your table, that's fine. Go to your table, go to your settings, change independent to ask, and I'll put 1/6 pi. And I get a number, and so it can't be that. If I do 4, I get a number.
Just 4 by itself?
Yeah, because this one says 4k, and then k is an odd integer. So I know these have numbers. Like this one was 1.01, this was 1.81. But then when I go to 3 pi, hashtag undefined. Okay, so 3 pi is undefined. So that's going to be it. Also, just reminding you, check inside here, it says odd. So that was when k was 1. We don't need when k is 2 because 2 is not odd. So then when k was 3, it would be 3 pi times 3, which is actually 9 pi. 9 pi. Okay, so here's a very good example where it doesn't say hashtag undefined, but you need to interpret it that way. It shows me 3e to the positive 13. So here's how you need to interpret that. That's going to be like a maximum at infinity. It's 3 and then 12 zeros, so to speak. And so that's where it's extremely high. And so calculator is just putting this instead of undefined, but it's supposed to be undefined.
So if it's e to the positive?
Yeah, e to a positive should be either infinity or negative infinity, which is undefined. E to a positive number should be either infinity or negative infinity, based on if it's like high up or low.
But e to the negative is just 0, right?
Well, let me show you what I'm talking about. If you do 3e to the negative 13, then that is really 0. So forth. But if it's negative 3e to the positive 13, then think of that as negative 3 and then a bunch of zeros, and so this is like negative infinity. So get used to all the different combinations. I know it's a little weird. You've got to be able to interpret your calculator. So we know it's the D answer, and then we've already said it's the OR if it's secant or cosecant. And we showed how to get that. Any questions? Okay. This one, your amplitude and period both have to be positive. So your amplitude would be positive 4, not negative. The other thing that's a little tricky on this one is it says plus pi halves, but you need to interpret that as minus a negative pi halves. And that means that the phi is your negative pi halves. All right, so for our period, we get the normal period divided by W, which would be 2 pi divided by negative 6, so we get negative pi thirds. Then we have to take our absolute value. So our period is pi thirds. Okay, then the phase shift is phi divided by W. So in this case, that would be negative pi halves divided by negative 6. So think of that as negative 6 over 1. Multiply your outsides and you get pi. Multiply your insides and you get 12. And your negatives cancel, so you get pi twelfths. So this one has negative pi twelfths, so that's not it. This one has pi twelfths, this has negative pi twelfths, and this has positive. So we're now down to 2 choices for our graph. Your phase shift should match the start. 2 of them matched and 2 did not. Okay, from there, let's graph it. So we have negative 4 sine negative 6x plus pi halves. Okay, so remember your W was your frequency, and 6 is a pretty high number, so that's why it's like that. And we want to go from from positive pi twelfths to about 5. And then our Y values are going to go from negative 4 to 4. Okay, so there's our graph. And so at pi twelfths, it's starting to go up, and this one's coming down. So that's why it's not that. It's this one. So again, pi twelfths, pi fourths, and 5 pi twelfths were x-intercepts. So if you're really stuck, notice pi force on this one doesn't go through the graph. But this one is on the graph. And it's an x-intercept. So if you really wanted to, you could look in your table and see about pi force. Like this, Control T, go to your settings, change it to ask mode, and go to pi force, and it says 0. So this one, the pi force is not even listed, like it's not on there, but this one has a dot for pi force. So again, that's how you can get it. Any questions? Okay, so again, what I used was from pi twelfths to 5, and I used from -4 to 4 for my window. Okay, the next one we have 2 cosine pi x minus 5 plus 3. So amplitude, W, phi, and then this is the vertical stretch. I mean, not stretch, shift, which they call B. So we have a middle line that would be y equal positive 3. Okay, so our amplitude's 2 from the number in front. The period would be the normal period divided by W. It's cosine, so you get 2 pi. And the W is pi, so you just get 2. So 2 straight answers that were 2. Then for your phase shift, we get phi over W, so that'd be 5 over pi. Right over left, basically. And it had negative, we change it to positive. So it's just 5 over pi. Again, a good logic check to know if you did it right or not. Well, these have 5, but this says 5 over pi, which is what one of our choices was. And this has 5, so it's not going to be A or C. Okay, so now let's graph it and see if it's going down at 5 over pi or going up. Two cosine pi x minus 5 and plus 3. Okay, so let's set our window. Now, it's a cosine graph, and so let's think about our window. Let's see. We start at 5 over pi, and then let's just go like 7 units. But then for the y part, we started our middle, which is at the 3, and then our amplitude was 2. So that means we go down 2 and up 2. So that means we're going from 1 to 5. Bless you. So that's how you know that both of these are still in the running, because this goes from 1 to 5. So I'm just trying to tie up loose ends for confirmation. You can see all of them go from 1 to 5, but that's how come. Because your middle was at 3. You go down 2, so that's 1, and up 2 to 5. Okay, so now let's graph our, without settings, 5 over pi with 7, and 1 comma 5. Okay, so at 5 over pi, it's starting to go down like this one. And this one was up. So it's B. Any questions? Okay. Okay, our next one, cotangent. So our amplitude's 1 because there's no number in front. Our W is 1/5, and our B is 3, which is our middle. Okay, so your period equal your normal period divided by W. Tan and cotan have normal period to be pi instead of 2 pi. So it's going to be pi over 1/5, and so you get 5 pi. Now some of these say 10 pi, but then this one says 2 pi, which we know it can't be. So just based on the period, we know it can't be C. Okay, so now let's graph it. Trig, cotangent, 1/5 x, and then plus 3. Okay, so at this point it just looks like that. Let's go to our settings on our window from negative 10 pi to 10 pi. And a couple of these go from negative 12 to 12, but then this one goes negative 2 instead of negative 12. I'm going to go from negative 12 to 12. And then if I have to adjust it, I will. Okay, so what I see is the y-axis is an asymptote, and this one has a y-intercept, so it can't be that one. So now we're down to the two that have an asymptote at the y-axis. Now this particular part could be the hardest part. On tan and cotan, what you have to do is figure out, is it really this close at negative 2, or is it further away, and is it really close at negative 12? So what happens at y equal negative 2? So at negative 2 on the graph it's kind of spaced out, but at negative 12 it's very close. And so that's how we know it's this graph. So it's close right there. So that's how you figure out the graph. Okay, for the domain, we know that if you just look at your graph, 10 pi has an asymptote, and when you take half, 5 pi would also be an asymptote. And so I know it's going to be D because of having asymptotes at 5 pi and 10 pi. Again, if you want to use your table for that, you can. Control T, go to your settings, independent to ask. If you put 1/4, you get a number. If you put pi, you get a number. But if you do 5 pi, you get undefined. So 5 pi is undefined. And then as far as the range, it's all reals, because There's no horizontal gaps. Okay, that's where we're going to stop for the day.